Uh-huh. Okay, so today we're looking at word problems, and we'll starting with question number 55 on page 249. We're going to look at a few word problems scattered through that are a variety of different topics, and this first one's on tree growth. So an evergreen nursery usually sells a certain shrub after 6 years of growth and shaping. The growth rate during the 6 years is approximated by the formula that's given there with dH over dt, meaning that that is the rate that the height grows over time. So that is a rate of change, or what we call slope formula. It says T is the time in years and H is the height in centimeters. The seedling is 12 centimeters tall when planted at time equals 0. Find the height after T years, and how tall will the shrub be when they are sold. So first of all, when someone tells you to find the height in T years, that typically means they're wanting you to make a formula. So in this kind of problem, since they've given me a derivative, I'm going to be integrating. So for question 55, we are going to integrate the formula of dH over dt. Hold on, let me change that a little slightly here. No, I'm not going to change it. I'm going to write the original problem up, but then I'm going to show you how to do this with the integration symbol. This will make sense based on what we've studied before. So in problems we've studied before, this is explicit format. We need it to be more of an implicit format where the dH and the dt aren't on the same side. So I'm going to move my dt over to the other side so that I can integrate just the dH on this side, and I can integrate 1.5t plus, that was plus 5, right? Plus 5 dt on this side. You need your dH and your dt to be on their separate sides so that you can integrate both sides, because that's what we would have done when we did a derivative. We would have took the derivative of both sides. So integrating dH is just h. And that may not make sense to you because you don't see a constant to change it back to a linear, but what constant do we not write? 1. So that 1 became 1h from a constant to a linear. And then over here, we're going to take 1.5t and add 1 to the power and put it on bottom. So 1.5 divided by 2 is how much? What's half of 1.5? 0.75? Okay. So 0.75 t squared, because we've added 1 to the power. And then our constant is going to become a linear. So it's going to be 5t plus c. Now, in a word problem, your final formula should never have a c in it. Okay? But when you start a question like this, you have to think about the fact that they gave you something about an initial value. They told me at the start the seedlings are already how big? 12 centimeters. So if I put the 0 in for both of these t's, that's going to go away. Does everybody see that? And that this over here has to be 12 for c because it's the y-intercept. And your y-intercept is always c because it's what is it at time 0. Does that make sense to everyone? Okay, so our final answer to question part A, this is all part A, is 0.75, and you decide if you want to write that 0 in there. You don't have to. If you don't like writing zeros, you don't have to at all. But we're filling in that 12 because they told me that's how big the seedlings were from the beginning. Now, once we get that C filled in, we are able to do any other math calculations that we need to do. For example, I can plug any time in and figure out how high they were. Or I can put in any height and figure out how long it took for it to get to that height, which is what they're asking me to do. How tall are the shrubs when they are sold? Well, when are they sold? All right. So in order to do that, we set t equal to 6 and plug that in our formula and calculate our height. And so how much of that you do in pieces is up to you. But when I was doing it, I was thinking about multiplying some of that out in my head so I could type less in my calculator. You may just want to type it all in the calculator. I don't know. It's up to you. I don't know the answer off the top of my head because I'm not looking at my notes. Hold on. 69? Everybody agreeing? So it's 69 centimeters because they told us up front that the height was in centimeters. Everybody understand where the units came from? Is you have to find them in your word problem? So integrating the rate formula changes it to a more simpler formula to calculate up your problem that in terms of generalization, like height or length or whatever they're asking for. Now, we're going to look next at number 57. And this is something we're very familiar with going forward, so I'm hoping going backwards won't be a problem. In order to do the questions around those at number 57, it gives you some information up above the question in bold. Vertical motion from 57 to 60, use a sub t equals negative 32 per feet per second as acceleration due to gravity, neglecting air resistance. So in this problem, they're telling us up front acceleration. Before, when we worked these questions, we started with the position formula, S sub t, and we took a derivative and we turned it into velocity. Then we took the derivative of velocity and we turned it into acceleration. Now we're going backwards. So our goal is to start with acceleration and integrate it and turn it to velocity and integrate it again and turn it to position, if that's what they asked for. So now we read the question. A ball is thrown vertically upward from the ground with an initial velocity of 60 feet per second. How high will the ball go? Okay, we've got to start with acceleration. They've told us that part. That a sub t is equal to negative 32 feet per second squared. I'm not into this per second. I don't like writing it that way. Now, what also that is, and what you may not be aware of until you think back to what we did before, that came from taking the derivative of velocity. So this is also dv over dt. So I'm going to integrate dv on one side and integrate negative 32t on the other side, dt on the other side to get my velocity formula. So when you're working problems that have rates, you have to integrate to get them to change to something else. So this is velocity equals, a constant becomes a linear, so I put a t on it, and I put a plus c. Now at this point, I might know something to plug in for c, so we always go back and think, what does c mean? At time 0, c is the initial velocity. So at time 0, how fast was I going with this ball? How fast is my ball going? 60. Is it upward or downward? Okay. So that means that my c is 60 because v sub 0 was equal to 60 feet per second according to our problem. So they gave us that initial velocity. So this c here represents my initial velocity. Now, that finds velocity, but the question is asking us to find how high it went. So velocity doesn't find out how high it went, it finds out how fast it was going. So we need to integrate again. Now, if you remember, velocity is also ds over dt. It's the derivative of position. So we can change the notation from v to ds over dt, and we can integrate it. So integrate ds and integrate negative 32t plus 60 dt. And even if you didn't remember that ds over dt is what v is, you know you're going to put s equals when you get done, right? So even if all you did was put an integration symbol over here on the right side of my problem, we know this side's going to be s because we're trying to find position. It's just better if you know the notations because it helps you to know what letter to put there. So what's negative 32t going to become? Well, I got to add 1 to the power and put it on the bottom. Oh, that sounds familiar. Does it sound familiar to you that have negative 16t squared in front of it? Okay. I'm going to write it a little lower because I'm running into that. And what's the 60 going to become? And it always puts the velocity in front of the linear, doesn't it, in the position formula. And then plus c, and c represents the initial position. Well, how high off the ground did it tell us we were in the problem? Why is it 0? That's right, it says from the ground. I shot this off from the ground, or I threw it off up from the ground. So my initial c drops off, and I just have the negative 16t squared plus 60t. Now, we have all our formulas. We've got to go back and rethink the math it takes to find the answer using calculus and not using what we're more familiar with from algebra. It asks how high it goes, which means I want the maximum, right? But I'm not allowed to go to the calculator and just put it in and get the maximum feature. I'm supposed to use the calculus behind it. So let's review. When you're at the top up here and you're at your maximum, how fast are you going? You're not. Your velocity is at 0. So if you set your velocity formula equal to 0, it'll tell you when you're at the top. So we do that first. So negative 32t plus 60 equals 0. We solve that for t. Okay. Okay. Thank you. So in that case, we have just 60 divided by 32, right? Because if you take it over, it'll be negative, and the negatives will cancel out. Is that a nice number? Positive 1.875 exact. Okay. 1.875 seconds. And I'm not going to round that off because I'm using it in my next calculation, so that's why I was asking was it exact, because I need all the digits. That's what time it happened. Did it ask me to find what time it happens? No, it asked me to figure out how tall it was. So now go back and store that or type it in the formula for negative 16, 1.875 squared plus 60 times 1.875. So you can calculate how high was it. So we're doing the same thoughts here, but we had to make the formulas a different way than we did before. What I said? I don't know. I didn't hear it either. All right. Has anybody got a number? 168. Anybody else getting 168 point something? I didn't look at my answer. Okay, let me turn my page back.
Oh, I didn't put negative. My bad.
Oh, you didn't put a negative? Okay.
56.25.
56.25 feet is the answer to the question. All right. So the key here is you have to know what they're giving you, what it represents, and because we're working in integration, we're having to work the formulas backwards and integrate them to get our position, to get our initial, and all the things that we already know how to do. Although, we kind of know this formula anyway. It's always negative 16t squared plus velocity initially times t plus the initial position. But they want you to show the work. So this is how you show the work. All right. We're going to skip down next to number 63. And question number 63 uses the directions in the middle of the page about vertical motion, where acceleration due to gravity is negative 9.8 meters per second per second. So we're going to do a metric one, which is probably what you're more familiar with. If you've done any of this in science class, have y'all done that? Okay. So this is number 63. And in this question, a sub t is equal to negative 9.8 meters per second squared. So we've got to do the same process that we just did on the last question, almost to a t, because you'll want to integrate that to get velocity. You'll want to integrate it again to get the position. The problem on 63 says a baseball is thrown upward from the ground with a velocity of 10 meters per second. Determine its maximum height. So it's almost identical to what we just did, except the gravity is different. Does everybody see that? All right, I'm going to stop the video and let y'all try this one on your own, and then we'll check it. All right, so we've done number 63 and found out the answer is 5.10 meters. So we're moving on to number 67. And if you read number 67, this one is very different from some of the others in terms of motion, because it's more along the x-axis versus going up and down for y. In the problems from 67 to 70, it says consider a particle moving along the x-axis where x sub t is the position that the particle is at time t, and x prime is the velocity, and x double prime is the acceleration. Now this one is starting very different because it is actually starting with the position formula instead of starting with acceleration, which I think is interesting. But what I also think is kind of interesting with this particular question is it goes back and really reiterates everything we learned about what does it mean when the velocity is positive, what does it mean when the velocity is negative, and that type of thing as well. So they use x sub t because they're moving along the x-axis. So think of it like this. You have a particle . Well, that doesn't look like a 1, but oh well. Maybe I should shorten that a little bit so it look like a 1. So you have a particle sitting here moving up and down this x-axis. Okay? The rate at which it moves and the acceleration at which it moves. If it moves in this direction, the velocity would have to be positive, and if it moves in this direction, the velocity would have to be negative. Why?
Because it's decelerating. That's acceleration.
Well, because it's going in a negative direction. Remember, velocity is all about speed and direction, the rate at which you're traveling. So when we talked about graphs, remember our graphs, how velocity was positive above the axis and negative below? It's all about direction. All right, so as we go through this question, we're really focusing tremendously on what each part of the problem is telling us. So with x sub t, the original formula, being equal to t cubed minus 6t squared plus 9t minus 2, it is only a good formula if our domain falls between 0 and 5. If it goes outside of that domain, this formula will not work. So that limits us already to a certain length of time that it's moving. This is time. This is not the numbers on the number line. These are the numbers on the number line represent how far you've gone. But this is time. So in part A, it asks us to find the velocity and acceleration of this particle. So if we take the derivative of this formula, that finds the velocity formula. And if you take the second derivative of the formula, it finds the acceleration formula. So this is power rule, right? Just real simple derivative. So what's the velocity formula?
3t squared.
and take the derivative again for the acceleration. All right, so now we have our formulas, and that's what it asks us to do in Part A. Now, Part B asks us to find the open t intervals on which the particle is moving to the right. And this is why I suggested talking about the velocity that we already knew something about before. Velocity is all about direction and speed. If we knew when the velocity is positive, then we would be able to understand when is that happening. So it's kind of like, and for the people in the video, I'm sorry you can't see this. Maybe you can. I can draw on the board. Okay. So I am walking to the right, and now I'm walking to the left. I was going in a positive direction when I was going right. I'm going in a negative direction when I went left. Okay? And so because of that, your velocity will be positive or negative when that is happening. Okay? So the first thing we need to do is figure out when is the velocity 0, because when I stopped going right over here and turned around and went left, that meant that it was 0 for just a little time period here. Does that make sense? Okay. So first of all, we are going to set 3t squared minus 12t plus 9 equal to 0 to figure out when that happened. Now, you're supposed to do this by hand. So what kind of factoring do I need to do to get started? Take out a 3, okay, because it might be factorable without that 3 in there by hand, and it might not. Now, if it's not factorable, we can always do y1, y2, or we can do quadratic formula or some other method. But usually, you know, you should always at least look at it and say, oh, I can take a 3 out. Maybe it's going to be factorable. So t minus and minus will make negative times negative make a positive. It add up to negative 4. What would that have to be for it to be 3 and add up to negative 4? Yep. Negative 1 and negative 3 multiply to be positive 3 and add up to 1. I mean, excuse me, add up to negative 4. So this will be 1 and 3. So I don't know what it did between 0 and 1. I don't know what it did between 1 and 3. And I don't know what it did between 3 and 5. But I know one thing. It changed direction because it was 0 at these times. So now we're going to make a chart. And we're going to do our intervals. Whoop. It's supposed to be at 1. From 0 to 1, because this problem starts on 0, it doesn't start on any negatives. Time can't be negative. And then from 1 to 3, and then from 3 to 5, you need to calculate a value in between each one of those in your V sub t formula. You need to calculate one for each one of those so you can see if it's positive or negative and make one of those positive negative charts like we've done before for sign charts. So I'm going to stop the video for just a second while y'all calculate that up. All right, so between 0 and 1, if you choose a half, did you get a positive or negative? Okay. And when you choose your 2, you got, and when you choose the 4, all right, I shortened my chart a little bit because I'm running out of room and I can't reach because of the cord. So now, based on our chart, when am I moving to the right? That's right. I'm moving to the right during these two intervals because my velocity is positive and right is a positive direction. So it means that for 1 second, let's say if we're talking about seconds, I walked to the right and then I turned around and for 2 seconds I walked to the left and then I turned around and for 2 seconds I walked to the right again. Does that make sense? Okay. Wouldn't you know the air conditioner came on? Where is that thermostat? Why is the air conditioner? Well, I guess it should. 75 degrees in here. Yeah. This one. Part C.
Jesse Joyce, please come to the front lobby.
In Part C, it asks us to figure out, find the velocity of a particle when acceleration is 0. What was our acceleration formula? All right, 6t minus 12 equals 0. Well, if you take a 6 out, that makes the answer more obvious, doesn't it? So at time 2, acceleration is 0. Now, the question asks, what's the velocity then? So that's why you have to go back to your velocity formula and plug in 2. And I went back to the one that was factored. Not that you have to, but let me tell you why I did that. Because I can plug the numbers in and do it in math in my head. And you're right, it's -3. But -3 what? Are there any units in this problem? No? Okay, well, I guess we won't have any units then. Well, maybe not. Maybe we should put some units, but not be a specific unit. So what is that negative telling me about my velocity?
It's moving in a negative direction.
Okay, and so that means it's on my number line. Now we got to think about on a number line, what does that mean? If I'm going to the left, what is happening on my number line? My x's are getting smaller. Okay.
Attention students,
So
please find the
decrease,
instructions.
see,
The following students should report to Ms. Covington's office at this time.
at
Alex Knight,
3
Autumn Knight, James Lawson,
units
Brianna Lester, and
per
Lynn Long.
second. So since we're talking about a number line, the spaces between the numbers are like a unit. We just don't know what it's measured in. And so it's decreasing at 3 units per second because the numbers are getting smaller as you go to the left. Does that make sense? Okay. All right. Now, do I want to do that one? No. We're going to do 2 more and we'll be done. The last 2 relate to the very last thing that we studied before we took the last test. It's about business calculus, okay? And we're looking at question number 77 and 79. And I wish, in a way, that these 2 questions had one more to go with it because it doesn't cover all 3 concepts, but at least it does cover the one that's a little bit more complicated. But in question number 77, it's marginal cost. It says find the cost function and the average cost function for the given marginal cost and the fixed cost when x is equal to 0. All right. So first of all, the formula they've given us in number 77 is the rate at which the cost is changing, which is 2x minus 12. And then the fixed cost is $50. And what does fixed mean? It doesn't change. And what thing in our formula never changes? The constant. So more than likely, that's probably what they're trying to reiterate there by saying it's fixed, that this is going to be your constant. So we're going to integrate dc equals, and then we're going to integrate, well, I got x's and t's mixed up. Is it supposed to be x or t's? Thank you. I got used to writing those t's, and now I want to write t's. Earlier today, I was trying to write x's for t's. All right, so we integrate up both sides of our problem by moving our dx over to the other side. So what we'll see the cost function be? X squared plus, excuse me, minus, you said minus, 12x plus c. Okay, so if I fill in my cost and what it would be if I didn't do anything, that would be 50, right? So I can put this 50 in here for that c, because that's the constant. That's the thing that's not changing. Fixed means doesn't change. Constant means it doesn't change. All right. It also asks me to find the average cost, C bar. So what will that be? Correct. You divide each one of these by x, because C divided by x is how you find that. All right. And that's all it asks you to do. That's what the question asked for. It said find the cost and average cost formulas. So now let's look at number 79. Number 79 is about revenue and demand. Now with the revenue and demand problem, they're asking us to find those two functions given the marginal revenue. So we're going to start off with number 79 with dr over dx equals 100 minus 5x. Now, did they tell me anything about my initial revenue? Well, let's use a little common sense. How much money can you make before you make money? Nothing. Because revenue stands for how much income you have coming in. And you don't have any income if you haven't started, right? So there won't be a C on this problem because C is equal to 0 because you don't have revenue if you don't have any money coming in because you haven't started yet.
Trying to figure this out pretty great, though.
Uh-huh. All right, so dr equals 100 minus 5x dx is what we're integrating to find our revenue formula. Now, once we get our revenue formula, we'll have to go back and talk about what is demand and how do you find that. But the formula is all about revenue, so at least if we integrate, we get the revenue formula. So 100 means what? All right, because it becomes constant to linear. And the minus 5x has got to become quadratic. So 5 halves x squared is correct if you add 1 to the power and put the power on the bottom. Notice that you're starting to pick up on that a little bit. You don't have to write down all that little notation maybe every time. You can do a little bit of it in your head sometimes with the power rule. Yay. All right, so now I'm not putting a plus C on this one because it was 0. But I could write one over here in my notes and then mark it out so that you remember it's 0. Because you always put 1, but then you plug the number in and it goes away on this one. Now here's what's tricky. Revenue is equal to x times little p, and little p is demand. That's right. If I want to figure out the demand formula, I have to divide by x. I have to take the revenue divided by x to find my demand. And that's important because in this particular question, it asks for both revenue and demand formula. So this weird italicized P thing, do the best you can, because that one looks really bad before I did this one. This one doesn't look too bad. It's going to be what? Oh.
That would be 5 halves.
5 halves, yeah. I left the 2 off, thank you. So it's almost the same thing as what your derivative was, but just a slight bit different because of that 2 on the bottom. So, how y'all feeling about these word problems? Not too bad?
Once you figure out what your constant is.
Mm-hmm.
I understand the math better now on what we're actually.
Sometimes I feel like you have to see demand more than one time to understand that it just represents this with the little p. I really truly think the first, and the other part of it is we're just not used to those kind of formulas either. So it gets easier. All right, so your assignment. It's going to start on page 249. And I'm just skipping around and picking certain even problems, so I can't say like something through something. 56, 60 and 62, 68, 'Looking at the question thing. What is it talking about? But then I saw there was a formula there. 78 and 80. So you have 6 questions. A little something on all of them. And what I'm hoping is that we can have a quiz this week on this section. So tomorrow we may do a worksheet on this section.